Hello students, you are welcome once more to the continuation of your tutorials. We're going to be looking at tutorial 2 still on week 11's work. We are going to be considering the tangency and average gradient between 2 points. Let's look at an example. It says determine the equations of the tangents to the given functions at the points indicated. Don't forget that the tangent is a line that is parallel to any curve, and this can be determined in calculus by finding our gradients at that point. So first thing to do is to substitute for x equals to 3 at that point in the function. That's what I'm doing there. If you substitute for 3 there and 3 for that, open the bracket and simplify, it gives you 0. So we can write that our x value at the point of tangency is 3 and the y value is 0. And that means it's our x1, y1. We can use that kind of subscript. Now, the next thing for us is to find the gradient at that point of tangency. To find the gradient, we differentiate that. And that's going to give us 6x minus 10. Substitute for x as 3 there, because that's your point of tangency, the x value. So if I put 3 there, it gives me 6 times 3 minus 10. My gradient will be 8. Now, to find the line that is tangential to that curve at that point, we use our line equation, which is y equals to mx plus c, or you use y minus y1 equals m into bracket x minus x1. I would prefer to use this one. So it means I've just put in the values. The x and y values there will be constant, and that means I need to substitute for y1, which is going to give me 0 there, and I'll substitute for x1, which is going to give me 3 there. And my m, which is my gradient, will be 8. So if I do that, that's my substitution. Open the brackets and make y the subject. So it means y will be equal to 8x minus 24. That is the function or the line that is tangential to the curve at that point. Let's look at another example. Here we are given that function and at that point. So the first thing is to substitute for x equals to minus 1 in that function to find the corresponding y value. If I put minus 1 there, I'm going to have that. Open the bracket for that to the power of 3 times that and add 7 is going to have minus 9. And that means that's my y value. So this becomes my 2 corresponding values, your x1 and your y1. And so the next thing is to what? Find the gradient. And to find the gradient at that point of x minus 1, you will have to differentiate that function. I'm going to be differentiating using my power rule. So it will be 3 times 2, which is 6, minus 1 from there, it gives you a squared. And then you differentiate x there, which gives you 1. At this point, substitute for x as minus 1 there. That's it there. It gives you minus 2 squared. It gives you 4 times 6 gives you 24. And that's your gradient. So using the line equation of y minus y1 equals to m to bracket x minus x1, this means my y1 will be minus 9 from there, and my x1 will be minus 1 from there. Put it that side. Opening the bracket there and solving for y, y will be 24x plus 15. Let's look at one more example. Here we're looking at our function. There is a cubic function at x equals to 2. Sorry, that should be x equals 2. Now the first thing is to substitute for x equals to 2 there. If I do that now, that's what I'm going to be having there. If I substitute using your calculator to do that, I'm going to be having my y1 as minus 1, having substituted for 2 there. So it means the 2 values at that point of tangency is 2 and then your y minus 1. Now the next thing is to what? We differentiate that to find our gradient. If I differentiate that, I'm going to be having that. And then you substitute for x as equal to 2 at the point of tangency. Put x equals to 2 for x there. Put x equals to 2 for x there. You're going to be having that. And that's going to be giving you 1. After doing that, we now have to solve for our line equation. And that's the formula there. So my y is constant. My y1 is minus 1. M is 1, which is already there. And then x is constant, x1 is 2. Opening the bracket and making y the subject, you have y equals to x minus 3. That becomes the line that is tangential to that. That's how to solve lines or equation tangential to any curve. Let's now look at how to find average gradients. Average gradients. Example 1 says, find the average gradients of the following functions between the indicated points. That is the function, and those are the 2 points. To find the average gradient between this point and this point of x, the first thing to do in that is to substitute for x equals to 2 in the function, and that's what I'm going to be having. I'm going to be having 12 if I substitute for 2 there, and if I substitute for 4, I'm going to be having 48. Now this becomes your x1, y1. This becomes your x2, y2. Now remembering what you did in 1018, that the formula for a gradient is y2 minus y1 over x2 minus x1. So we are going to apply that rule here. And so this becomes my x2 minus x1, which is 48 minus 12. And then, my y2 is 48 minus my y1, which is 12. And my x2 is 4, and my x1 is 2. And that's it there. And you do that, you divide, your gradient will be 18. Now let's find the second example's gradient. Here we're given minus 5x squared, so it should be minus 5x squared in that question. At the points given, minus 1 and 1. So if I do that here, I put my minus 1 first, and if I do that, I'm going to be having minus 7. And I put again my 1, the second value of x, I'm going to be having minus 3. And so my x1 is minus 1, my y1 is minus 7, my x2 is 1, my y2 is minus 3. Applying the formula for the gradient, I'm going to be having that. This is my y2, which is minus 3, minus my minus 7, which is my y1, over x2, which is 1, minus 1. If you do that with your calculator, you're going to be having 2. That's how to find average gradient.